Hello, I'm Carter Roosh, and welcome to Lab 1, Charged Tape. Let's get into it. The purpose of this experiment is to explore concepts of electrical charge by determining how much excess charge is on one piece of charged clear tape. We can approach this by floating tape B above A, and in doing so, we balance the electrical and gravitational forces, and that helps us compute Q, or the charge of tape B. Here are some general physics principles and models we'll be using. We'll be using Coulomb's law, Coulomb's constant, the charge of one electron, and the atomic scale. Some assumptions for our experiment are tape A and B have equal charges, and that electrical force equals gravity at the floating point. Here's the experimental setup. We have tape B suspended between two vertical sticks, and then we bring tape A underneath, and then we measure the upward movement or the floating point of tape B when it's repelled. Here's my script, and I used Coulomb's law as well as the calculation for the force of gravity, which was mass times gravity, and here I found the magnitude of the charge. So here's a general breakdown of the calculations used. First, we had to find the force of gravity on tape B, so we simply just took the mass of tape B and then multiplied it by gravity, and we're given this value. And then next you need to take that force of gravity and equal it to the charge, because at the floating point they are assumed to be equal. And finally we have the charge of tape B. In order to find the number of electrons, you just divide the charge of B by the electron constant. And we have this. Next we find the number of atoms on the tape. And first we just take the dimensions of the tape, we find its surface area, and then after we have the area of the tape, we divide it by the atom constant, and we have this many atoms on this amount of tape. Next, we have the ratio of electrons to atoms. We just take our electrons, divide it by the atoms, and now we have this value, and that means 1 in 10 million atoms on the tape carry an excess electron, and that is responsible for the result you saw whenever you saw the tapes repel. So some sources of error to note could be imprecise measurement of distance, which easily can make the resulting charge too high or too low, or charge leakage. Some charge may leak to your hand, and the effect would be that the measured force is smaller than it should be, so the calculated charge is too low. Finally, we have some what if and what does it mean discussion questions. Finally, we have some what if slash what does it mean discussion questions. The first one we have is, what if electrons had positive charge and protons had negative charge? In short, the behavior of attraction and repulsion between charged objects would stay the same, only the labels for positive and negative charges would be reversed. And as to the why is it important to handle the charged tapes as little as possible, this goes into my sources of error just previously stated. Touching the tape lets charge leak away through your body, and this can cause the tapes to lose their charge, making the experiment less accurate. And that will be all I have for you today. I hope you enjoy.